They said it was impossible, that no one could take the twisted remains of scrap metal and turn it into the heart of one of the most feared war machines of the Second World War. But Mechanic Johnson, a man whose hands knew more about engines than textbooks, stared into the rubble of a downed P-51 Mustang and saw something the engineers did not: a challenge, a chance, a spark of defiance in a world consumed by conflict. It was 1944, and the skies over Europe were a theater of relentless chaos. The Luftwaffe prowled the clouds with lethal precision, while Allied forces scrambled to keep pace, not just in men and strategy, but in machines that could decide the fate of nations. The P-51 Mustang, with its sleek frame and roaring engine, had become the symbol of hope for the Allies. It was faster, more agile, and could escort bombers deep into enemy territory. Every Mustang that took to the skies carried with it not just pilots, but the dreams of entire air forces. Yet, war is cruel, and the P-51, like any other machine of metal and fire, was not invincible. Each mission was a gamble. Each skirmish left behind a trail of wreckage, twisted fuselages, shattered propellers, and engines that had ceased to breathe life. And that is where Mechanic Johnson entered the story, a man whose ingenuity and grit would blur the line between genius and madness. Johnson was not a decorated officer, nor was he a famous engineer. He was a mechanic, one of the countless unsung heroes whose sweat and skill kept the engines of war humming. But unlike his peers, he had a vision. While others saw scrap, he saw potential. While engineers shook their heads at what seemed like hopeless remnants, Johnson imagined a symphony of pistons, valves, and cylinders coming together, resurrecting life from metal death. The world outside was a vortex of destruction. Bombing raids left cities in ruins. Soldiers returned home hollow-eyed, carrying the weight of battles they could hardly describe. And in the shadow of this chaos, Johnson scavenged the remnants of a downed Mustang, pieces scattered across a makeshift workshop in the English countryside. He worked in secrecy, for the idea of rebuilding an engine from scrap was not just unorthodox, it was seen as lunacy. The historical backdrop of his endeavor was as volatile as it was inspiring. The P-51 Mustang, developed by North American Aviation, was initially designed to be a long-range fighter, capable of protecting bombers on perilous missions deep within enemy territory. Its engine, a Rolls-Royce Merlin, was a masterpiece of precision engineering. But during the war, manufacturing could not keep up with attrition, and replacement parts were often scarce. Johnson's task, therefore, was not merely creative, it was necessary. Without engines, Mustangs sat idle, grounding pilots and leaving the skies to the enemy. As he began his work, Johnson faced challenges that would have broken the spirits of most. Every part he salvaged carried the scars of combat, cracks from cannon fire, pitting from corrosion, and warping from heat. The precision required to assemble a functioning Merlin engine was staggering. A single misaligned cylinder, a poorly machined valve, or a misfired spark could doom the entire project. Yet, Johnson approached each obstacle with a meticulous mind and a stubborn resolve. He became part alchemist, part artist, coaxing functionality from the dead metal, whispering life into inanimate machinery. The world of 1944 was not kind to dreamers. Factories churned out engines by the thousands, yet they were often far from perfect. Engineers, bound by protocol and mass production, found Johnson's approach reckless. "It's madness," they muttered. "No man can restore an engine from scrap to operational capacity." But Johnson did not work for accolades or recognition. He worked because he understood the intimate truth of engines, that beneath the scorched steel and fractured components lay potential, waiting for someone brave enough to unlock it. And so, in a small, dimly lit workshop, with only the hum of tools and the occasional whistle of the wind outside, Johnson began to assemble a miracle. Bolt by bolt, cylinder by cylinder, He recreated the heart of the P-51, often improvising with tools and materials that the engineers would have scorned. Each day, his progress was a quiet rebellion against the chaos of war, a statement that human ingenuity could still triumph even amid destruction. By the time he reached the final stages, the engine resembled nothing less than a resurrection. Parts that should have been discarded now fit together seamlessly, a testament to Johnson's skill and vision. Yet the question remained, would it work? Could a machine, pieced together from the remnants of destruction, roar to life as if the war had never touched it? Or would this dream, like so many others, collapse under the weight of reality? And as Johnson tightened the final bolt, stepping back to look at the engine in all its improvised glory, the world outside seemed to pause. For in that moment, amidst the smoke and rubble of war, a single question loomed, one that would either cement Johnson's place in history or relegate him to the footnotes of impossibility. Would this engine, born from scrap and sheer determination, fly? The answer, when it came, would shock not just engineers, but the entire Allied effort. And the story of how one man turned madness into triumph was only beginning. The workshop was silent, save for the occasional clink of metal and the steady, deliberate breaths of Mechanic Johnson. Outside, the war raged on, bomber formations droning across the sky, dogfights flaring like distant fireworks. But inside, time itself seemed to bend around the impossible task at hand. Johnson was about to test the engine that no one believed could work, a heart of scrap that might just beat once more. The initial assembly had been grueling. Every component had to be reworked, pistons painstakingly machined, crankshafts realigned, valves reshaped to exact tolerances. Tools were borrowed, improvised, even smuggled from nearby factories, for official channels would never sanction such a reckless experiment. Johnson worked alone, driven by a combination of obsession and necessity. Allies were losing aircraft faster than factories could supply them, and every grounded Mustang was a gamble with lives and missions. Some days, Johnson nearly despaired. The engine would seize, bolts would snap, or combustion would misfire in ways that made him question his sanity. Yet, with every failure came a lesson. He learned to listen to the engine as though it were a living being, interpreting subtle vibrations, the smell of fuel, the rhythm of gears as a language only he could understand. Where engineers saw scrap, Johnson saw potential. He saw history waiting to be rewritten. There were moments of brilliance, almost miraculous in their clarity. He discovered that certain warped parts could be straightened with controlled heat, that worn bearings could be salvaged by polishing and reshaping, and that scavenged metal from other downed aircraft could substitute for missing components. Every innovation was a risk. One wrong adjustment could end the project, or worse, lead to catastrophic failure. And yet, the stakes made Johnson meticulous. Every bolt torqued, every gasket sealed, every connection checked multiple times. The Merlin engine was complex, with over 1,000 moving parts. Johnson improvised what manuals deemed impossible, often making small tools from scraps of metal to reach confined areas. He reverse-engineered solutions on the fly, creating new parts where originals were beyond repair. He was not just rebuilding an engine. He was recreating a masterpiece in miniature, a symphony of metal and fire orchestrated by a single human hand. Finally, the moment came to see if the engine would breathe. Johnson wheeled it to a test rig, a crude assembly of stands and clamps that he had cobbled together in a barn. His hands shook as he turned the ignition. There was a sputter, a cough, and then a roar. The sound was deafening, a deep, alive growl that seemed impossible from what was, mere weeks ago, a pile of wreckage. Smoke curled upward, blue and acrid, as the engine vibrated under its own newfound life. Johnson stepped back, awestruck. He had done it. The scrap had become a beating heart. Engineers who had scoffed at him arrived, skeptical at first, drawn by rumors of a miracle. They circled the engine, measuring, testing, listening. Their eyes widened. Every reading matched or exceeded factory specifications. They muttered in disbelief. Johnson had not merely rebuilt an engine. He had improved it subtly, ingeniously, in ways that even their standardized production could not replicate. What they had called madness, they now recognized as genius. Behind the triumph, however, there were hidden stories few would ever know. Johnson had faced sabotage from jealous colleagues, bureaucrats who feared what his success might imply, and the constant threat of air raids that could destroy months of work in minutes. There were nights he worked by candlelight when fuel shortages left the workshop cold and dim. Each failure could have ended in disaster, and yet he pressed on, driven by an unspoken code, that every plane in the sky was worth risking everything for. There were also moments of ingenuity that seemed almost too clever to be true. Johnson discovered that certain alloy impurities, usually considered defects, could actually enhance engine performance if treated correctly. He fashioned tools from discarded artillery shells, adapted cooling systems from unrelated aircraft, and even repurposed parts from agricultural machinery. Each solution was a testament to human creativity under extreme pressure. In the midst of total war, amidst chaos and despair, a single mechanic was bending reality with nothing but skill, intuition, and relentless determination. Once the engine had run successfully on the test stand, the question became whether it could perform in the skies. The first flight test was a tense affair. Pilots approached the rebuilt P-51 with caution, their hands shaking slightly on controls that had once seemed routine. But as Johnson's engine roared to life beneath the aircraft's polished cowling, a collective sense of awe settled over the airfield. The Mustang taxied, then lifted gracefully into the air, its flight flawless, its power undeniable. The impossible had become reality. Word spread quickly through Allied ranks. Johnson's engine became a legend before it even left the airfield. Pilots nicknamed it the Resurrection, a symbol not just of mechanical brilliance, but of hope itself in a war that had demanded so much from everyone. Engineers were forced to acknowledge the brilliance they had once dismissed. Johnson's methods, once derided as madness, were studied and adapted, changing approaches to salvage and repair throughout the Allied effort. Yet, even in triumph, the story carried tension. How many engines could Johnson rebuild? How long could such a fragile supply chain of ingenuity last under the pressures of war? And, more importantly, could this single act of brilliance turn the tide, or was it just a flicker against the vast machinery of global conflict? As the Mustang returned from its first test flight, gliding smoothly over the fields of England, the world began to realize that something extraordinary had happened. Johnson had taken the impossible and made it real. But the story was far from over. The true test, one that would cement his legacy and challenge the very limits of human skill, was still to come. The skies were watching, the engines were roaring, and one man's defiance of reason was about to face its ultimate reckoning. The day of the ultimate test had arrived. Johnson stood at the edge of the airfield, the P-51 gleaming under the muted English sun, its engine, a marvel born of scrap, ready to roar. Pilots and engineers gathered, whispers carrying through the tense morning air. Skepticism lingered, yet beneath it, a flicker of hope pulsed. This was more than a mechanical trial. It was a testament to human perseverance, to ingenuity that defied the boundaries of what was thought possible. As the Mustang taxied to the runway, the ground itself seemed to hold its breath. Johnson's hands were steady now, betraying none of the countless sleepless nights, the hours spent coaxing life from metal, or the frustration of repeated failures. The engine, a patchwork of salvaged parts and improvised ingenuity, pulsed beneath the cowling, vibrating with potential energy. Every observer could feel it, the sense that something extraordinary was about to unfold. The pilot, a young officer named Lieutenant Harris, climbed into the cockpit, his eyes reflecting both awe and nervous anticipation. The ignition sequence began, the engine roared, and the Mustang surged forward with the force of a living creature. Dust and gravel kicked up behind it, wings slicing the wind with precision honed in combat. And then, as if the aircraft itself recognized the courage poured into it, it lifted into the sky with a grace that seemed almost defiant, almost triumphant. Up above, the war-torn landscape stretched endlessly, a mosaic of scarred earth and fragmented towns. The P-51 flew smoothly, its engine purring like a beast restored. Maneuvers that had been impossible on a fragile, damaged engine were executed flawlessly. Loops, rolls, and tight banking turns, all performed without hesitation or falter. Johnson's creation was no longer a miracle in a workshop. It was a living, breathing instrument of war, ready to join the fight against tyranny. The engineers, who had once whispered doubts, were forced to acknowledge the truth before their eyes. They measured performance, recorded data, and checked tolerances, each reading confirming what seemed impossible. Johnson had not merely rebuilt an engine. He had created one that met, and in some cases exceeded, factory standards. Every hesitation, every misaligned bolt that they had feared would spell disaster, had been accounted for, adjusted, or improved by his relentless ingenuity. Behind the spectacle, however, lay untold challenges. Johnson had to operate in secrecy, balancing limited resources against the enormous demand of wartime production. Rumors of sabotage, bureaucratic interference, and logistical obstacles followed him. Yet, through it all, he persevered, driven not by accolades but by necessity, a recognition that every functioning engine could tip the balance in countless missions, save lives, and carry the war a little closer to victory. The impact of Johnson's achievement rippled far beyond a single test flight. Allied forces began to re-examine salvage operations, adapting his methods to recover engines from wreckage and damaged aircraft. Factories studied his improvisations, discovering that creativity under pressure could complement mass production, not replace it. Johnson had transformed what was once considered lunacy into a blueprint for practical innovation, proving that necessity and human determination could bend the rigid rules of engineering and war. Pilots who flew with Johnson's engine reported an almost mystical reliability. Aircraft that would have been grounded or lost to mechanical failure now soared, protecting bomber formations, intercepting enemy fighters, and striking with precision. In the theater of war, where every advantage counted, one mechanic's determination became a force multiplier, turning scrap metal into a weapon, a lifeline, a symbol of hope. Yet, perhaps the most remarkable legacy of Johnson's work was not technical, but human. Stories spread across airfields, barracks, and factories about the man who stared at twisted metal and saw a beating heart. He became a legend, a reminder that even in the darkest days of total war, courage, creativity, and perseverance could defy expectations. His work inspired mechanics, engineers, and pilots alike to look at challenges differently, to see opportunity where others saw despair. After the war, Johnson's name did not dominate headlines, and he did not seek recognition. The world moved forward, rebuilding and remembering the great battles, the generals, the policies. Yet, those who knew the story carried it like a secret talisman. They knew that in a small barn in the English countryside, one man had accomplished what seemed impossible. One man had taken the debris of destruction and breathed life into it, changing the course of countless missions and leaving an indelible mark on history. Decades later, aviation historians still tell the story. Museums preserve the surviving Mustangs, engines meticulously restored, but few exhibit the ingenuity hidden in Johnson's methods. His legacy lives not just in medal and flight logs, but in the enduring belief that human ingenuity can triumph over circumstance, that even in times of unparalleled destruction, one determined individual can make the impossible real. And so, as the engines of war finally fell silent, and Europe began to heal from the scars of conflict, the story of Mechanic Johnson endured, a testament to courage, determination, and the indomitable human spirit. A reminder that sometimes the greatest victories are born not in the heat of battle, but in quiet workshops, amidst the hum of tools and the resolute beat of one man's vision. The Mustang that once lay in ruin now soared in history, and Johnson's name, whispered among those who understood true innovation, became immortal. Because in a world driven by machines and war, it was a human heart, fearless and unyielding, that had turned scrap into triumph, and in doing so, had changed the sky forever.